All right, so part two, this is going to be worth about 25% of the grade here. There's about 7 or 8 questions on Socrative. I attached a textbook for you to read and answer on Socrative. Make sure you go to A1, A3, or AB55. And there's an assigned text. I attached a text to Google Classroom. It's called Atomic Spectra, Atomic Color Code. And then the last part of the assignment here is called Complete the Simulation. Okay, light from a photon. Okay, and luckily we get to use this photon calculator. So let me go ahead and let's slide this over here for right now. And let's minimize this here for a quick second here. So I'm going to go ahead and click on this simulation here, and let's see what happens. Okay, see what it looks like. Okay, all right. So it looks like this here, and I do have and when you click on the photon calculator, this comes up over here. Okay. All right, so it says here, light from a photon. Now let me go ahead and do some drawing tools here. Let's do some annotation. Okay. All right, so in this problem here, we have an electron that's at the second excited state. This is the first excited state. So, and then this over here, remember n equals 1 is the first energy level. The first excited state is called n equals 2, right? This here is called n equals 3, which will be the third energy level. And this here, we'll call this n equals 4. Now, this is called the ground state. The ground state is like the first floor. Okay, so if an electron goes to a higher energy level, it's called the first excited state, which is energy level 2. If we go to the next excited state, which is called the second excited state, is actually energy level n equals 3. And then the third excited state is actually energy level n equals 4. Okay, now take a look over here at this over here. Notice how we see this EV here, EV. Okay, so I'm going to write down here EV. EV is called electron volt. Okay, it's just a new unit, electron volt. Okay, now I'll tell you why this is going to be easy. This is just a different unit, like meters or yards or inches. It's just another type of unit. Now see this right here? So EV is electron volt. Now I want to ask you a question. What is easier to remember? 1 electron volt equals 1.602 e to the minus 19 joules. So which is easier to remember? 1 electron volt or 1.602 times 10 to the minus 19 joules? Obviously, 1 electron volt is easier to remember. Okay, now let's go back to here. Now, see how these are negative signs? Let's ignore the negative signs and let's just do absolute value. Absolute value. Okay, so when I do this problem here, what I'm going to look at is that, notice here, I'm going from here to here. So I'm going to do what's called a change in energy. What is the actual change in energy? Okay, so let's take a quick look here. So I went from 19.1 electron volts to 28.9 electron volts. So what's the actual difference? So if we need to, for purposes of calculation, let's just go ahead and just put down here 28.9 electron volts here, right? Minus, up here we have 19.1 electron volts, okay? So if I do that difference here, take my calculator, and I have here 28.9 minus 19.1, that gives me 9.8 electron volts, okay? So now let's take a look at how we use the calculator. So over here is the calculator. Let me go ahead and do mouse here. Let's kind of move this around a little bit here. Okay, so what's the input amount? So our actual, to go from here to here, it took 9.8 electron volts. So let's go ahead and put in here 9.8, right? 9.8. Now, we have to pick the correct units. It's not wavelength, it's not frequency, but it's photon energy, electron volts. There's joules, MeV, but we want electron volts. So there we go. Now, the question is, what wavelength in nanometers of the photon emitted by this transition? So as it drops from here to here, there's a photon given off. What's the wavelength? Okay, so let's make sure we understand what's going on. An electron goes from here to here, it's given off a photon, right? What's the wavelength of this photon? So we'll go back over here. So I look over here and I see, now it says in nanometers, right? So I look over here, here's nanometers here, and this is 126.51. So let's go ahead and do this again. So I want to look here, right? Okay, because it's in nanometers and it's 126.51. So I go over here, let me go ahead and write down my name. I'll go ahead and write down here Thanos. And the wavelength is 126.51. Let's hit submit, and hey, it says great. Your answers are within the allowable range of error. All right, so that concludes our discussion. So make sure you use the YouTube video to answer the questions and do the simulation and so on and so forth. All right, that's it. I'll catch you guys later, and we'll go ahead and do stop recording. Peace out. Love you guys, 3000.